Anyways, 2.8. Solving inequalities in one variable. So honestly, overall, this is very similar to what we did in 2.7. The difference with it is with inequalities, we're not looking for equal to 0. We're looking for either greater than, less than, greater than or equal to, less than or equal to 0. So that means we have to account for all possible values that make it true. So, essentially we're going to end up with like polynomial inequalities that we're dealing with. So you're going to have things that look like a fraction, if you will. So the problem that we like just did on the board, like when we went over 15, like if we had just changed the sign to be like greater than or equal to, that problem would have been a completely different problem. So the answers that you're going to get, how we got like 0 and 5 or whatever, that is the same. But it's figuring out, now you have your answers written, then they look like a domain because you're looking at all possible values that work. So, look at example 1 to start with on page 236. Do what? I don't want to say no, but it's not exactly a line graph like you're thinking of. 236. I'm going to try to stick it up here just so it's not like, it's probably going to fall. It's just going to be awkward. Okay, so let f of x equal x plus 3, x squared plus 1, x minus 4 squared. Okay, so this one is not written as a fraction, so they can technically be either way. Some will be written as fractions, some will just be written like this. Anyway, so it says to determine the real number of values of x that cause f of x to be 0, positive, or negative. So, first of all, we need to find all the zeros, okay, and the multiplicities of them, which the multiplicities aren't as important with this stuff because it's just like a double 0 there, basically. So the real zeros are at -3 and 4, because this x squared plus 1, if we set that equal to 0, you're going to get x squared is equal to -1, so it's going to be equal to I. And obviously that's non-real, so we don't have to worry about that one. So part B, I don't really think about it as the way that they do the part B. I usually kind of like, I don't want to say I skip it, but I jump to part C and just do it there. So they look at each individual piece and then they decide like, okay, where, like, is this positive, is it negative, blah, 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 which ultimately we're doing, but I do it all down here in this step. So any real 0 that you have, you mark on a number line. Okay, so they had -3 was a real 0 and 4 was a real 0. So you put both of those on there. And then you pick a value that fits in each of the spots and you test and see if it's going to come out as negative or positive. Okay? No. So basically, like, I'm going to start here with this one. Okay, so -3 to 4. I need to test a number in this range. The easiest one to test is 0. Okay, like, typically, the numbers that I'm always going to try to test if they're in the range is 0, 1, -1. Okay, those are the easiest. And if not, then I'm going to pick the next easiest number to fill in. So I'm going to put 0 up here anywhere I see x, and I'm going to see what happens at each of these. Okay, so if I plug in 0, x plus 3 is positive. So that's where they get the positive sign here. If I plug in 0 here, it's also positive. Okay, 1 is positive. And then if I plug in 0 to x minus 4 squared, then obviously that's 0, so then I have -4 squared. Okay, so they're showing the negative squared. I normally will go ahead and just write it as a positive. Okay, so I don't do this like extra square thing that they're doing. And when we actually do examples on our own, it'll be easier to see, but I'm just kind of trying to walk you through what we're going to see. So then this whole section is positive. So from -3 to 4, we are positive. Okay? So now, I know this is really blurry. Let me see if I can focus it back in at all, if that'll help. It doesn't like to read, like, books for some reason. A little better. So then, let's just go over here to the left now. Okay, and I do normally work my way across, but I just wanted to do the easy one first, like using 0. So I can pick anything that's negative, anything that's past -3. I could pick -1,000 if I want to, but it's not really, I wouldn't pick that. I'd pick like -5 probably, because it's just something that's easy to work with. So I put -5 up here for x, so that makes that term negative. So I write on a negative sign. If I put in a negative here, well, the negative is being squared, so that's going to come out positive no matter how you look at it. Okay, and that's what they're talking about up here. For any number that you put in, that factor is going to be positive. So they just write that all down as one step. I just wait till I get down here and I just do it. Okay, so I have negative for the first one, positive, and then if I plug in -5, -5 minus 4 is -9, but square it, it's going to come out to be positive, so I'm going to have technically a negative, positive, positive, so that whole thing's going to be negative. So from -infinity to -3, it's negative. Okay? And are we following that kind of? Well, so if it's an odd number of negatives, it's negative. So like if all 3 were negative, it would be negative. If 2 are negative, it's positive. That's basically, well, essentially here we have 2 negatives. And then on this side, you can pick, again, any number that's past 4. You could pick 1,000,000 if you want. I wouldn't, but you can. Okay, I usually like to pick like 5 or something like that that's close. 5 plus 3, that's positive. This one, always positive again, so it's 25 plus 1, that's positive. This one, 5 minus 4, okay, that's 1, but again, it's squared, so that's going to also be positive, and so that whole thing is positive. So, technically speaking, 4 is not positive. 4 is 0, right? We said up here that it's a 0. So, when I go to write this, the way that I write the positive values is I write -3 to 4, okay, and then 4 to infinity. And we typically are going to use that union sign, the little U, okay, like we did with domain when we do it, just to show that that's what it's like all going together. Okay, and we want to make sure we have open brackets because it's not including these numbers here because these are zeros. Oh, I still have a bunch of people that don't know that in my classes. It is, I mean, it is confusing. Like, it's not something you grow up hearing, and then all of a sudden in 7th grade it appears, and you're like, what? Yeah. And then the other one, okay, it's negative, from -infinity to -3. Okay, and then if it does ask for the zeros, then you're going to want to obviously list x equals -3, x equals 4 for the zeros. So let's go ahead and do one of those before we, like, go on too far. Let's see. And the same principle of what we just did would apply if it is given as a fraction to you. You do it the same way. I'm going to try to find one that's not to do first, though. Okay, so 1 through 6 is essentially like what we just did. So somebody pick an even number. I don't want that. So 2, 4, or 6? 4? All right, we're going with 4. F of x is equal to 5x plus 3, x squared plus 6, x minus 1. Okay, so first and foremost, I want to find my zeros. So, what are my zeros? Wait, what? Are we sure this is right? Okay. No, I didn't. That's why I was like, wait a second. Okay, but what does that mean about this one? Okay, it's not real, so I can just get rid of it. It's not a real zero. I don't need to worry about it. It's up there. It's on the board. The pi. He said to get real. I know, I was like, it's right there. Alright, so now we want to draw the number line, okay, and always make sure you write, like, left to right, okay. I have people that, like, they just are like, oh, I'm just going to throw 1 on there, and I'm going to throw -3/5, just wherever I please. That doesn't work that way. Alright, and a lot of times, just to keep things separated, like, I'll, like, draw out, like, the lines up a little bit higher, just so it's easier to see. Yeah, that's imaginary, because it would have an I in it, so we only want the real zeros. Alright, so I want to test different values, okay, so let's just start over here. Okay, so I need something bigger than -3/5. What's bigger than -3/5? Well, when I say bigger, I really mean smaller, but a number that's larger than -1, okay. So plug in -1 up here. What do I get for each of these? Okay, negative, positive, negative. So what does that mean is actually happening over here? It's going to be positive. Okay, how about from -3/5 to 1? What number do we want to check? 0. So plug in 0 up there and tell me what we have in each spot. Positive, positive, negative. Okay, meaning this is what? Negative. And then over here. Okay. Meaning it's what? Every once in a while I get someone to say negative, so, you know, gotta check. Okay, so then we'll wrap it up here and write the answer the correct way in just a second. But just so you know, like, this is something that will get used again in calculus. It helps to figure out, like, when you're drawing a graph, it'll help you to figure out the shape of the graph, where it's increasing and decreasing, where the concavity changes, things like that. So being able to do these charts, like, this might seem really basic right now, but, like, it does get, I don't want to say it gets harder, but, like, it gets more useful. It gets more useful the more you go in math. So, like, getting an intro to this now is really good, because I think I didn't get to cover this section last year, because I think it was, like, I finished 2.7, I think, before Christmas last year, and when we came back, I just didn't even think to go back and do 2.8. So, like, trying to teach, like, Ryan in calculus this year, he had never seen this before, because I didn't get to it last year, because I just didn't realize I didn't cover it. What? Okay, so I mean he did he did fine with it because it's not really that hard. But if he'd seen it, you know, in pre-cal, it would have made it a little easier. All right, so I need to write my answer. Okay, so for this first one, I'm gonna show you how to do it. Okay, so obviously where we have our zeros, okay, at x is equal to negative 3/5 and x is equal to 1. Okay, it's positive from negative infinity to negative 3/5 union, because it's also positive from 1 to infinity. Okay, and those are open parentheses on all of those. Or the parentheses on all of those. And then negative from negative 3/5 to 1. Okay, so big things I'm looking for, okay, when you draw up your, like, homework, basically, all this right here is what I'm looking for. Okay, because I want everything written out, like, nice and neat. So I want to clearly show what your zeros are, so make sure you label them like this. Okay, it just makes it easier than me having to go through and try to, like, look through your chart and find them. And that way I make sure that that you know what you're talking about. Okay, so list your zeros, list your positive, list your negative. Doesn't necessarily have to be in that order, but just make sure you have all the pieces. Let's look at 6 just because it's kind of interesting. F of x is equal to x plus 2 cubed, 4x squared plus 1, and x minus 9 to the 4th. Until we hit trig next chapter. I think it's next chapter we hit trig. Just kidding. It's exponentials and logarithms first. But I think that stuff is fun. I enjoy logarithms a lot. Fun fact, it's the first thing I ever taught in math. Logarithms and exponentials. Taught a pre-cal class at public school. First thing I taught. So I like it. Well, I did like student teaching stuff there in Bethel. I had to for my thing at Thomas Nelson. Anyways, alright. So what are my zeros here? So the thing to remember when you're doing this, okay, and that's why I wanted to look at this one, is that you have x plus 2 cubed is equal to 0. So we have to still, if you remember, well, I don't think most of y'all had Mr. Cass, so you probably don't remember the undo what's being done to it in reverse order. Okay, so the first thing that we need to get rid of is the cube. So, yes, so we're just left with x plus 2 is equal to 0, so then x is equal to negative 2. Okay, so then how about this one? Okay, let's look at this. Okay, so what's the first thing I need to get rid of? Okay, 4x squared is equal to negative 1. X squared is equal to negative 1/4. What's true of this, though? It's imaginary. Don't need it. Then x minus 9 to the 4th is equal to 0. Okay, so the ones that I'm actually dealing with is x is equal to negative 2 and x is equal to 9. That was weird. Alright, so I need to check values in each spot. So, far left one. Okay, some negative number that's, I guess, smaller than -2 technically. -3. What happens if I put -3 in for x in each of these? Okay, it's negative because -3, this is going to give you -1, and then -1 cubed is still negative. Okay, is there any way for this term over here to ever be negative? Nope. Okay, so this is negative. How about this one? What should I do from -2 to 9? 0. Probably the easiest option. I mean, honestly, you can use whatever. I mean, you could use -1.276 if you want, but I wouldn't. It doesn't. Yeah. Like, I wouldn't pick -1 just because negatives throw in an extra factor that could throw you off. Like, I would use either 0 or a positive number, unless the only option I have is to use a negative number, like all the way over here. So, 1 or 0, either one, what happens when you plug that stuff in here? Okay. Positive, 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 meaning it's? And how about this one? Okay, so how do I write it up? So we have to remember that we can't include 9 because 9's a 0. And negative. To make sure the negative infinity comes first. I bought blue and white ones for winter. I'm sure he would love that. Yeah, those are frowned upon now. After my class, I think. We didn't do anything bad. I actually don't. Literally, our senior prank was going to be a fake wedding for a teacher. With one of the students in the class. Well, I mean, it didn't actually ever happen. We just joked about it as a class. We were told we couldn't do one, and we would get in major trouble if we did one. My cousin's class put 2006 balloons in the upstairs hallway. Because Mr. Law's birthday is like around the time of graduation, senior pranks, all that stuff. The class actually before me had gotten in trouble because they decided that they were going to have a senior nap in the hallway. So they all literally brought in like sleeping bags and pillows and everything, and literally at the end of lunch, they took a nap in the hallway. So people couldn't get to their lockers. Yeah, it was funny, but like it was they were kind of in the way, and Well, that's what the teacher said. They said, if they're in your way, just step on them. And I was like, okay. So then they were like, they got in big trouble for that, which I was like, okay, like really? Like that's not something that really caused an issue. But anyways, they got in trouble. And then the senior class set up a really, really, like, good thing. So, like, they had, like, basically gone to the administration and just said, like, okay, we're not going to do a prank, like, whatever. So they had Miss Patton call over to the office one day, like, on Mr. Law's birthday, and was like, you need to get over here. Like, they're setting up a really bad prank, and it's going to, like, it could, like, really, like, harm the school. Like, it could burn down the whole school and all this other stuff. So he and Mr. Fletcher, like, Mr. Fletcher was, like, in on it, so he knew about it. He, like, booked it over here, and the whole, like, Miss Patton's room is, like, got, like, wrapping paper down the door and, like, all this other stuff. And so Mr. Law just, like, busts in, and it's a birthday party for him. So they, like, freaked him out just for a birthday party, but it was really funny. I was like, okay, like, that, you know. He wasn't super thrilled about it, but he was, like, he, like, appreciated it. It was just, yeah. So senior pranks haven't really happened since that year. So that was actually the year before me, but I wanted to get 3 pigs and number them 1, 2, and 4 and let them go. But but it was kind of frowned upon to do that, so. No, I wanted like a pig. I wanted like a pig. Oh, no, I wanted like a pig. Or like, I don't know, a dog. I didn't care. I just wanted some kind of animal. Just for Alyssa to hear later. Anyways, it was a good time. That no one looks at anyways. Oh yeah, like it used to be if you had some way to get access to a set of keys, it was super easy to do it. Now it's like not possible because they have like motion detectors and stuff that'll set alarms off and I'm about it. Love a good alligator. Yeah. Okay, these ones that are say we're like graphically, we're not doing those. Get rid of that. 7 through 12 is basically the same thing we just did. You just have to factor it yourself. So we might do one of those in a minute. I was trying to see what other examples we needed to look at. Just as a refresher, I don't know if we're going to have any that come up like this, but if y'all remember right before Christmas, we did problems where you had to figure out all possible zeros, check them on your calculator to figure out which ones actually were possible, and then use synthetic division to verify them. I mean, yeah, you could have. They were all decimals, so it would have been hard probably to come up with them unless you had a bunch of like weird fractions that you didn't check, but oh, well, yeah. Anyways, so just refreshing the fact that you can do that. Okay, you just basically numbers on top, numbers on bottom, and check them all. Mhm. Yeah, it's always the one on the far right that goes on top. So after you do that, obviously then it can factor into stuff, so then you can factor it down, and then you're basically at the step we just did. They're still like checking the end behavior and stuff, but honestly you just get to this point. So that's the other thing, like see at this one they have 4 spots they had to check. Okay? And you can get out of what they're saying, you can get out of checking these ones technically by just looking at their end behavior. But I think it's just easier just to plug numbers in. So like the more factors you have, obviously the more gaps you're going to have. That's the big thing. So let's look at another, oh wait, do we? I don't even know if we have time to look at another example. In like 6 minutes, so I don't think we have time to do another whole example. Basically, so just like a rough, just like intro, okay, and we'll do the more examples of these tomorrow. But stuff like 7 through 12, because they have inequalities in them, now we could possibly have a greater than or equal to or like less than or equal to, and if that's the case, we would basically be using brackets in some cases rather than parentheses. Okay, so that's going to be the big thing that's different with these ones when we go to do them. We won't do the graphing ones like I said. We'll probably look at stuff like 25 through 32, which is essentially like what we did yesterday, but doing it with inequalities, finding like the different values, or if something's like undefined, that's another option, and on top of the 0, positive and negative. Just solving using a sign chart, which is what we've just been doing. So we'll probably do a couple more examples, and then depending on how much time we have left tomorrow, either you'll have problems to do for homework or we'll have time in class on Friday to work on them. And then review for a quiz probably Monday and quiz probably Tuesday. Probably what we're looking at. So, well, actually, not Monday. Review for quiz Tuesday, quiz Wednesday, because we don't have school on Monday. And I really don't want to give you guys like homework over the weekend either to like have to study. Enjoy a long weekend. So somebody's going to have to remind me, though, because I'm going to forget. And I'll be like, oh, yeah, your quiz on Tuesday. Just, you don't have school.